Okay, welcome to week 5. This week we're having a look at what I've labelled some analysis questions, and that's for you to just to identify, because we need a meta idea, don't we? What's analysis and what's application? So we're interested in understanding the difference so that we can be more careful and discerning about how we deal with analysis, because when it gets to analysis, we need to take note of some things. All right, so let's have a look at some inequalities. Initially, I want to just draw your attention to this one. This one says x is positive, so it's a funny place to start, but x is positive. So x is greater than 0, but x is positive. So forever we could say x is positive. What about x is negative? X is negative. So I'm going to put that in inverted commas because that's how I want you to say it. So when you see the value, you can write x is negative. So they're your first analysis ideas that I've been talking about. And so hopefully that'll take for you, and you'll understand it. When we see those, we refer to them as x is positive and x is negative. Anytime there's a greater than 0 or less than 0, we could say that quantity or the interval or the amount or the blob even is less than or greater than 0, is positive or negative. That's how we want to say it, positive or negative. All right, so let's have a think a little bit about how these things work. What we've got here is an example. So we've got x is greater than 1, so that's the one that we're referring to here. The greater than symbol uses this circle. So on the number line, you can have different types of circles. Some will be coloured in and have a different meaning to the ones that are not coloured in. Likewise, when we use brackets, brackets will have a different meaning depending on their shape for this set notation, this kind of idea of what's included and what's not included. So in the case of the circle, it's not included. So it's not part of the calculation. Okay, this one is included, this value, whatever that value is, and included, whatever that value is. So we'll get used to doing that. So in this case here, the value 1 is not included, denoted by the circle. And so if it's not included, then we would say that it's got a round bracket, because it's not included. And so the round bracket would then say, comma, and where's this arrow going? Where are you going, mate? Off to infinity. Off to infinity. And so we wouldn't include infinity, because infinity is an abstraction, a human idea, and it's something that we would just put to. Okay, so we would put that to infinity in our own thinking rather than in a solid physical sense. All right, so the next thing we might consider is the other form. There's two forms. Yeah. So look out for the forms, because this one here actually means the same thing. Why would we do that? Why would we have them on the opposite side? And in most things that we do in maths, when it seems unreasonable, we're doing it for convenience. Okay, we would do it for convenience. So the inequalities say the same thing. Why? Well, I would suggest convenience. Okay, it's just to get you in the way that you want to interpret it. One of them, x goes on, and all the values of x are greater than this number 1. The other way of saying that is that the number 1 is the boundary. So use that idea. Number 1 is the boundary, and all the x values, because 1 is less than all the x values head off in this direction to the right. So it's very important that we get this right, because you'll use this in Maths 2. Maths 2 will ask you to deal with inequalities a little bit more significantly than in Maths 1, and it's important that we get those things right. So what about this guy here? X is less than 1. So again, not included, denoted by the circle, and so it represents all the numbers going that way. Okay. What's the other form? 1 is greater than x, so 1 is the boundary. 1 is the boundary, it's on the left-hand side, so it's the boundary. All the numbers fall below 1. In this particular one here, we've got x is less than or equal to 1, so 1 is included, so we see that it's coloured in. And the symbol is included. So for the equivalent form, all it's doing is putting the number on the other side, but when it does that. Okay, so we need to get used to this convenience idea because it's a very confronting thing for students who haven't dealt with inequalities largely before. So please listen to me about this because there's some other rules that confuse. There's other rules not related to this that have nothing to do with this. And so it's very important that we get that. All right, how do we interpret x is not negative? X is not negative. Well, that would mean that on the number line, our boundary would be 0. Now, 0 would be included because it's not considered negative, so we would colour that in. And where we've got the nice formal block shapes, I'm just going to do this. Okay, and that one tells me that we go off to infinity. So we can say x is greater than 0. Okay, in notation, we would include 0 with a square bracket, and then we would go off to positive infinity with a round bracket. What's the alternative way of doing that? The alternative way is to put the 0 on this side and say that 0 is less than or equal to all the different values of x. So we just want to keep the language simple, okay, and make sure that we understand the brackets and the inclusions and when it's not included. Okay, included, not included. All right, we've got a typical form of an inequality is s less than or equal to -6. So this is where your number line skills come in, variable C. I told you to revalue your number lines. There's -6, and it's saying less than or equal to -6, so it's going to be included. Okay, and x is less than, so it goes that way. So it goes off that way. All right, how would we do that? Well, minus infinity, we can't include minus infinity, but we can include -6. Okay, so the square bracket. So you'll get used to that over time. But again, remember today, the emphasis is this is an analysis topic. So we're just going to be very, very selective about how we include all of our thinking around this. All right, so if we have a look at some examples in the use of those previous ideas, okay, sometimes the forms can be a bit tricky, and the forms are a different idea to this idea. So if we add and subtract numbers to treat it like an equation, we can do that. But what about if we multiply or divide both sides by a negative number? So this is a very important rule, okay? Now, we change the inequality and change the numbers around. The difference with the rule and this one is that we put this over this side and this over this side. We swap them around. See that? Number, quantity, number, quantity. Same up there, number, quantity. We swap them around for the sake of convenience. Here we're saying they would stay. They would stay. And so if we had x is greater than 1, and we multiply this equation by -1, we would multiply both sides, times by -1, times by -1, and so we would get -x minus 1, but we would have to change the inequality around. Okay, so multiplying both sides means that we would change the inequality. So this is slightly, now look, the x's are still on the same side. The numbers are still on the same side. So this is not the convenience step. This is a new rule. Okay, so if we take the inequality and we can do the maths, it doesn't affect adding 2. Okay, so if we add 2 to both sides, what you do to one side, you do to the other. So we get 5 is less than 7. Okay, if we subtract 4 from both sides, these are just examples of the maths operations. So we go back to our original inequality. Okay, and we would subtract 4 from both sides. 3 minus 4. Okay, 3 minus 4 would be -1. 5 minus 4 is 1, but we don't change the sign. Multiply both sides by 6. 3, 5, we're going to times through by 6. So we get 6 times 3. What you do to one side, you do to the other. 6 times 5, so we get 18. It's less than 30. Okay, so nothing's changed. We haven't changed anything. Okay, but this time we're going to do a division. we're going to divide the inequality, divide through by -1. So we're going to have 5 over -1. What you do to one side, you do to the other. And what's happened this time? Dun, 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 dun. Aha. Now look, they stayed. Okay, I don't necessarily think this is the best example, but they stayed. Okay, they stayed and the sign reversed because of this rule that's now in place. So we have to take that into account. Okay. In these, so that's an interesting point for us to consider. Okay. All right. So let's have a look at some examples. Sketch them on a number line. Wow. See, it was always important. Always. All the numbers less than 4 or all the numbers greater than 8. So we've got the maths of that. We've got less than 4 and all the numbers greater than 8. So we've been able to put that together. And in here we've got all. Now all represents union. In set notation, it's a union operation. So if we put this together, and we're not included with 8, so off you go. And we're not included from 4, so off you go. That's how we're reading the greater than or less than signs. So in set notation, the negative infinity and 4 not included is union or with 8 and infinity. Okay, so we've got all of the values that occur in both of those sets. In this particular example, there aren't any values that sit in both. So it means all of the values in this group down here and all of the values in this group. I said aren't here, but all of the values in both groups. All right, so all the numbers greater than 1 and this time, and less than 4. So we'll put an and in. This one is intersection. Intersection. Okay, and the way that we develop that is that we'll do our number line first. So we've got 1 and 4. So x is greater than 1, so off you go. And x is less than 4, off you go. Now this represents an interval which we're going to express in a slightly different way, but here we would have everything from not including 1 up to infinity. Intersection, there's our intersection symbol. Just notice the difference. This is a smiley face, it's an upside down face, and negative infinity all the way up to, but not including 4. Okay, so this overlap means that basically you're getting all the numbers between 1 and 4. So this is a bit harder to divulge, you see. So we get all the numbers from 1 up to 4, not included. Now, very importantly, the way that we can write this interval is that we can say 1 is less than x is less than 4. So we've got an interval as the result of an intersection. There's that phrase again, intersection. And. Okay, so we need to be mindful of how that operates. Very, very important. So sometimes we get inequalities with just split terms, and sometimes we get them grouped like this, the result of an intersection. And we call this an interval. So that's the interval. All right, all the numbers greater than 4 and less than 3. So if we do this on the number line, so we've got 3 and 4. They're not included, so greater than 4 is that way, and less than 3 that way. So in this case here, what does that mean? Well, in the all case, we did take all the numbers, because you could have all of these this side, or any of these this side. In this case here, because we don't have this picture of the crossing over or the intersection, we can say that there's going to be a funny result. So if we go from 4 to infinity, not included, and intersect that with negative infinity to 3, what we'll end up with is the null set, or the empty set. So that's one that we need to be aware of. Okay? So lots of information, analysis type information that we can use. Alright, let's have a think about solving linear equations. Now again, for me, I don't like doing solving just on its own. I want to understand what's the geometric interpretation, so we'll be looking at that as well. Now in this case here, literally what this would say is that if I interpret this as a function on the left hand side, that is y equals x plus 3, and this is a y value. Okay, so what does that mean? It means that if I set it on a graph and drew it like this, we'd have x plus 3, okay, and y equals x is this form, so x plus 3 is a shifted y equals x, okay, so that would be y equals x plus 3, and then up here we would have the number 7, and as a y it's just going to be straight across. So this one's asking all of the values that are less than 7. What are all of the values that are less than 7? Okay, so let's have a look at what that might mean, because that's not going to be easy to draw that. In a little while we'll do regions, but for the moment we're just looking at it this way. Okay, so let's continue and do some mathsy on this. Okay, let's put it over as, we'll do undo. What you do to one side, you do to the other. So x is less than 4. So that's the solution. The solution is x is less than 4. So we would draw that on the number line. We would draw 4 not included and swish. And that tells us that that is the solution for this inequation. Geometrically, what does that mean? It means that from 4 down are these solutions. That is, from here, if we draw up where they intersect, there'll be a point of intersection. Then everything to the left of that is a geometric solution. So we can solve the equation and do this part readily. Great, that's wonderful. However, it has another meaning. So the other meaning is better described using technology. So we'll turn to Mathematica, and on there we'll be looking at Mathematica in the version of the online. Okay, and so we're going to have x plus 3 is less than 7. So show me what that looks like. X plus 3 is less than 7. And so here you go. Here's our x plus 3. And I want to plot it. I want to plot it really from 0. So I'm going to put plot, and I really want it to be from, say, minus x. So I'm just going to put comma x should be from minus 1 dot dot to 5. Let's see if it'll process it like that. Let's see if it'll make sense of that. There you go. Look what it's done. It's joined up for us and shown us what's happening. So there's our shifted to 3. That's the main reason I did that. So it shifted it up to 3. It's y equals x, so it's 1 for 1 everywhere we go. These scales are not the same, but that's why it looks a little bit slopier. But it's less than 7, and look where 7 is. 7 is at 4. Okay, so this is everything below this. So everything less than 7. So if we look at that from the point of view of our graph here, just very quickly pulling your attention back to everything to infinity. So off you go to infinity, so we can kind of say everything off to infinity, that direction. It's less than 7, okay? Off to negative infinity. And down here it's the same. Now, I don't agree with the idea that we would do this, because this doesn't mean a region. That's not a region, that's just a bunch of values, okay? So I think the geometry shape there is probably a little misleading. But anyway, let's just move on from that. You'll see a lot of different things in a lot of different curriculum systems, and that's okay too. Now, if we take that lens and we look at this one here, this is x on 3. What's x on 3? Y equals 1/3 x. So if this is a y value, this is a y value. So what we should be having here is a y equals x on 3, which would be through the middle, but it'd be less steep, wouldn't it? It'd be less steep than that, so it'd be about 1/3 as steep. Okay, and the number 5 would pop up here somewhere. So 2, 3, let's call that 5. Okay, so there's a line 5. Okay, so what we're doing this time is we're looking to see how does it interpret geometrically. Now, of course, we can solve this. Okay, we can do the solving thing. So let's do that. But it has a different interpretation, doesn't it? I mean, we can do the number line thing, and that'll be helpful. So we're going to multiply by 3. So we'll have 3 times x over 3 is greater than 3 times 5. They will cancel. And so we'll get x is greater than 15. Okay, x is greater than 15. So that means that on our number line, we go all the way up to 0 and all the way to 15. It's not included. And so we just go, whoosh. Okay. So everything from here, guess what that's going to be? 15 divided by it, so it's going to be 15 at that point there. Okay. So what does it mean to say greater than or less than that particular value? Well, the number line tells you the x values that we're interested in. But then we've got the idea of the equation, okay, the geometric interpretation. Over here, the y value was less than 7, so all the values less than 7. Here, the y value is greater than 5. So could it be that it's going to be all those values up there? So let's check it. Use technology. You know, there's nothing wrong with using technology, okay? And we'll call this one 15. And you can always put that. Now we'll just do that just as a general one, but I don't think it's going to show us what we want. We're going to need to extend this off. There you go. So we need to extend that off a bit further. Let's make that 25. Let's see if Wolfie will give us that. So 25 till, oh, look at that. Okay. So even more, probably we're going to have to go for maybe 50. Let's go up to 50. Let's see what comes up there. Oh, there you go. There's your turn there. That's 45, isn't it? 3 15s are 45, which means I've got to go back here and check this. 3 by 15, 3 by 5. 3 by 5 is 15. X on 3 is greater than 5. X on 3 is greater than 5. So you've got to get your technology right, because that's not going to help you otherwise. Okay. So we can clearly see. So we can pull this back to 20. So that's what happens when you're rushing around, isn't it? Using technology to assist you. So everything greater than 5. So all of that shaded area that goes on to infinity, greater than 5. So if we come back to this area here, this was the suggestion I made earlier. All of the area here represents the geometric interpretation of this inequality. So you can solve them. By all means, solve these. Help us to find this point. But there's also a geometric interpretation, and that's really the value of this work going into something like Math 1. Okay, so we can do the same interpretation for all of these things. All right, we can put the lens together for all of them. Some of them will need some pre-work, some of them won't. So what's your y? 4x. 4x is a steep one less than or equal to 10. So we can just do the maths of it. So we can divide by 4. So we've got 4 and 4. They'll cancel, 1 in disguise. So x is less than 10 on 4. 10 on 4 is 5 on 2. Divide 10 by 2, divide 4 by 2. Or if you like, 5 times 2, 2 by 2. That's 1 in disguise, so you're left with 5 on 2. So that one there can be drawn fairly easily. So we go to 5 on 2, which is 2.5. But this time we colour it in because it's included. And we go less than. Whoosh, all the values of x are less than, but they can be equal to. So we're going off to infinity. Don't do an 8, Jason, but do a symbol that represents infinity. Okay, so there's our infinity symbol. Moving off, and then we've got 5 on 2, but this time it's included, so the bracket needs to be square. Okay, square bracket means included. So those 3 symbols together tell you about the inclusion. Okay. All right. What about the geometric interpretation? Well, 4x is fairly steep, and less than 10 equal to 10. This time 10 would be up here, so that would mean everything less than. So use your Wrk1, get your practice, get used to it. Okay, x on 10 is less than or equal to 4x. 4x is the original one, and it's less than 10. So let's see what, now, just with your placement of your inequality signs, it's not liking that less than or equal to, so what we're going to do is change that and put less than or equal to. See, that little change in the symbol irons out the problem for us, and we now get the correct symbol being displayed to us. Okay, so in this case here, everything that's less than 10 for our function, everything that's less than 10, so that implies that everything that's less than 10 here, all of this information here is part of the solution going off to negative infinity. Okay, and this value here would be 5 on 2. So your geometric interpretation can be just as important as you're doing your equations. So this one here, 6 minus 3x is greater than 15, just to give you an idea. 6 minus 3x is less than greater than or equal to. So this time we'll just swap that around, leave the equal sign where it is, and we'll call that 15. And so we get a sense of greater than or equal to 15. So 6 minus 3x greater than or equal to 15. Why didn't you plot that for me? So it's telling me that it plotted it, but it's not giving it to me. And maybe I'll just take that out for a moment, that might be the error that I've made. There you go. So the value is all negative, you see? It's all negative, so we might make it go to 1 and go -5. So please plot for us x between -5 dot, and what do we reckon? +1. That might be okay. Let's see what that does there. Oh, there you go. Look at that. Okay, so it's showing us clearly where the shifter is. We'll have to work that out, what the x value is. So we might go just one more to 2. Okay, and it's saying for this function, everything that's greater than that number 15. Actually, we're going to go one more to 3. And just to get the x-intercept in there at 2, okay, because we're going to need that. And we've also got this value here, which will be -3, but the geometric interpretation is showing us it's off to the left. So let's do that one. So we've got a shifter, and we've got +6, and -3 is quite steep. And then way up here we've got 15. And so everything that's greater than that, so that's going to be above 15 for that function. Okay, between 15 and the function. Between 15 and the function is this space up here. everything under the function greater than 15 going off to negative. So curiously, we can do the number line idea. Okay, this time we can subtract 6. So what you do one side, you do the other. So minus 3x is greater than or equal to 6 and 9 is 15. Now we'll divide by negative 3. Careful, negative 3 is negative. So what's going to happen? We're going to do a negative 3 and a negative 3. They'll cancel as one in disguise, and x will be 9 divided by negative 3 is negative 3. What do we do here? Okay, the rule says that we have to reverse this now. Okay, so what we find is that x is less than negative 3. So if we write our 0 and our negative 3, it's equal to, so it's coloured in, and off you go to infinity, everything down there. So in this case here, this will be negative infinity, but this time we'll have negative 3 included. See, now that doesn't necessarily inform you with your graph, because it's this point here, that's negative 3. So yes, that's the intercept, and we can solve for the equation and work the intercept out, but this one here is highlighting that the value we're solving for is the point that leads to the negative. In the interpretation. So it's a little bit tricky, isn't it? It's a little bit tricky. Now this is like pre-work. We have to do a bit of pre-work here. So what we'll be doing is adding x, so there's no multiplication. 5 apples plus an apple. 4 apples plus an apple is 5 apples there. I thought it and said it. So 5x is less than 9. So in our interpretation, 5x is very steep. Okay, and then the value 9. Okay, so it'll be looking for all the values less than 9. Okay, all the values that are less than 9 for our function. So we're going to come under and go to the left. So 4x, and it should interpret it. So let me do it the way it was put in the question. 4x less than or equal to 9 minus x. Wolf is smart enough to work out what's going on there. Now, if it doesn't print, it's because I've not got these numbers correct, and they're not correct. So we're going to just fix that up. The minus 5 is all right, but I think we need to probably come up to 10 or so. Let's have a look at that. So while that's doing that, we'll have a look at this. And so we've got 4x, 5x minus 9. So we can divide by 5, divide by 9. So therefore x is less than 9 on 5, which is 1 4/5. So if we go to 0 and 1 4/5, which is also 1 4/5, and we're including it, so we're putting the circle coloured in, and we're going off to the left. So that's minus infinity, not included, and 9 on 5 included. Okay, 9 on 5 included. So the positive, the 1 4/5, that's this one here. That's the value at which we start to look whether we go left or right. And because it says less than, what we've got is our less than. So in actual fact, this one's being a bit more literal than I'd hoped for. So what I'm going to do is put the x over and call it 5x and take that one off because it's being more literal than I'd hoped for. But yeah, that's much more what we were interested in. A steeper one, they're very different, aren't they, the scales? So just be mindful of that. The shapedness of the graph is always normalised to 1, so on Wolfram, so you can change that, but just be aware of that. So the scale's changed to normalise it to a slope of 1. So back here, less than. So everything less than. There you go, off to infinity. Off to negative infinity, so that's less than. So the geometric interpretation is just as important as solving your particular value, because what does the particular value mean? So we try and get geo meaning as well. Okay. So for me, that's 30 minutes there. So I'm going to stop this video and come back to these problems. Be back soon. That was part 1.